Today in this video, we would be looking at how scaling up and scaling down is done in AWS, Amazon Web Services. To quickly revise, if you're increasing the amount of resources on a server, that is called as scaling up, and if you're decreasing the amount of resources on a server, that is called as scaling down. Before we go into the practicals on how scaling up and scaling down is done, to understand how scaling up and scaling down is done in AWS, we first have to understand how resources in AWS are categorized or displayed. Here we have a quick diagram from AWS itself, wherein we discuss the number of CPUs and the memory that's available for our consumption. If you see, we have something called as a T3 nano instance type, wherein we get 2 CPUs and 0.5 gigabytes of memory, wherein a T3 micro has 2 CPUs and 1 gigabyte of memory. A T3 small has 2 CPUs and 2 gigabits of memory, whereas a T3 medium goes with 2 CPUs and 4 gigabytes of memory. Similarly, if we go for T3X large, we get 4 CPUs and 16 gigabytes of memory. The highest in this configuration is 8 CPUs and 32 GB of memory. Now, in order to increase these resources on an running or existing server, there is a certain process that we would have to follow. Now, this is a typical drawback in scaling up and scaling down, wherein with every change in the resource in AWS, we would have to restart or reboot the servers, or basically stop the server, increase or decrease the resource utilization, and then start the server. What happens in AWS is this virtual machine or EC2 instance, which is running on a T2 nano, is rebooted and started on a T3 small server if we increase it from T2 nano to T3 small. Similarly, if we go from a T3 medium to a T3X large or a T3 large, the instance would be rebooted and would be given and would be running with the higher configuration. And during the boot up process, the operating system would use the kernel to read the hardware and get the resource utilization. In this case, because these are virtual machines in the background on AWS, this would rely on the hypervisor which is being used on AWS to get the CPU and memory configurations. So, in order to change the resources on an EC2 instance, in the scaling up and scaling down process, we would have to stop the instance, change the configuration, and start the instance again. Let's quickly look at how this is achieved in the AWS console. For this, I will go to the EC2 console of our AWS in the US East region, that is North Virginia region, and let's create an EC2 instance with a certain configuration in our mind. I'll take a Windows instance to show you how this is done so that we could visually see it on an easy way. We would be here selecting the instance type, so I would be selecting 1 CPU and 1 gigabyte of memory. I'll select the key pair that I would use to decrypt the instances. As you see, I don't have an existing VPC in this region, so let's quickly go to the VPC console and create a default VPC for us so that we could get the resources up and running. What I do is I'll just click on create a default VPC, and this should give me the basic architecture that is needed to support our EC2 instance. I've selected the EC2 instance. I'll also select any of these subnets that are available for us. On this, the auto assigned public IP is enabled, but what we could be doing is so what we would be doing is going further and adding the security group. So we are creating a new security group saying allow the TCP on the public internet. Also, I could also select an existing security group if we have any. I'll say this as public RDP access, which is not a good idea on a general sense, but works totally for us in our test environment. So I'll launch the instance, and if I go to the EC2 console for this EC2 instance, I should be able to see my instance going to the pending state and coming to a running state very soon. I already have an IP address that we have received on this for this instance. So we'll wait for the EC2 instance to come up. This can take anywhere between 3 to 4 minutes depending upon the utilization or the resources that are available. Since we are running a very low utilized, since we are running on very low resources, that is only one CPU and 1 gigabyte of memory, so this definitely would take some time for coming up. In the meantime, I could also get an instant screenshot of to see what exactly is happening on the Windows console. So if you see, the Windows is booting up, and we currently are waiting for the login screen to come up. So I'll collect the public IP address and go to MSTSC and connect to the EC2 instance. We will have to wait for the connect option to be enabled on this EC2 instance. That's when we know that the instance is available for us to connect. In the meantime, we could continue monitoring the screenshot of the EC2. If you see, this is already in the Control Alt Delete unlock screen. That means the server should be accessible now, and the connect is also now available. I'll go to the RDP client and I'll click on get password. And this part is where it generally takes time for the operating system to set a password and AWS to recognize that the password has been set and get the information. So now if I try to connect to this EC2 instance on this IP address, I should be able to see the login screen at least, but then I will not be able to decrypt the password at the moment because we just have to wait for the client to get the password. So let's try to get the password. I'll go to the security tab in actions and go to get Windows password. If you see, I'm able to go to the place where this is asking. If you see, I could go to the place where it is asking us for the PEM key to be provided. I'll go inside keys section and I'll provide the PEM key. I'll decrypt the password. Once I get the password, I could go inside and click on login. We'll have to accept the certificates provided by AWS, and I should be able to see the login screen. So if you realize this EC2 instance would be terribly slow because we are just running on one CPU and 1 gigabyte of memory. There are also EC2 instances of servers available in AWS which have 0.5 gigabytes of memory. That's half a GB or 512 MB of RAM. Whereas most of the smartphones that are coming in do come with a higher variant wherein we have like at least 6 to 8 GB of memory. But if you see, this is the number of CPUs that I have. It just says one virtual processor and 1 gigabyte of memory. So our target was to increase, so let's increase the size of the instance. So there is an option in actions wherein I can go to instance settings and click on change instance type, but this is disabled at the moment because the instance is in the running state. I could stop the instance and this should go to the stop state very soon. So if you see that the EC2 instance has now come to the stop state, so what we could do is go to actions and go to instance settings and go to change instance type. I could click on the drop down and this should give me a list of options that I could select from. What I will do is, since we have discussed only T3 series, I'll come down to the T3 series, wherein we are currently in the T3 micro, which is this guy over here. The next one would be a T3 medium. If we go to our setup, so after T3 micro we have a T3 small or T3 medium. So let's take it to T3 medium, wherein we have 2 CPUs and 4 GB of memory. Now I'll select this, I'll click on apply. So what would happen is the instance type would change to T3 medium. All I have to now do is start the instance and this should come into the pending state. Very soon this would come into the running state as well. So, and now if you see that the IP address has changed. Now this has happened because we have not selected any constant IPs to be present on the server. So that means that the IP has changed and we would have to connect to the server using the new IP address. Now if in case we want to maintain the same constant public IP address, we should be selecting something called as elastic IPs. I'll open this, I'll open the same prompt and I should be able to look at this window. This time it should not take a huge time for us to decrypt the password because this is not a first time boot but just a restart. So we'll wait for the instance to come into a 2x2 check. Now that is typically where AWS would know that the operating system is available for taking in transactions at the moment, at that point in time. We'll quickly wait. Let's try with the old password and see if it still works. I'll try the old password and see if that still works. Yeah, basically says that the login attempt failed. So let's wait for this to come to a running state. I could go to security tab and click on get Windows password. I'll click on this, decrypt the password. If you see that the password has definitely changed. Earlier it was starting with some T blah blah blah. Now if we launch the instance, this should be giving us the console. Now this is scaling up, wherein the earlier configuration was a T3 micro, wherein we had 1 CPU and 1 GB of memory available on the server. This EC2 instance that we are now looking at should have a higher configuration. So let's wait for the console to come up. And I would quickly go to the task manager and we go to performance settings, and if you see, it has 2 CPUs and then 4 gigabytes of memory. Now that should be identical to what we had, 2 CPUs and 4 gigs of memory. Let's try to take the server to the highest in the T3 range, that is T3 2x large. I'll follow the same process. I'll quickly go stop the instance. We'll have to wait for the instance to go to the stop state. So as you're seeing, right, every time we are stopping the instance and then waiting for the instance to come up, and a lot of that happening. Now in this process, what's happening is there is an unavoidable downtime that is getting added to the instance, and this is definitely going to impact the behavior or the availability of the applications. So whenever you're doing a scaling up or a scaling down activity on the EC2 instances in AWS, it's always recommended to get a downtime on those resources. The downtime could be a minimum of um, 5 to 10 minutes. That's because it takes some time for the instance to go to the stop state, and then it also takes some time for the instance to come into the start state and availability to be present. So I would go down and let's increase the instance to some other material, wherein let's take this to T32X large, which should be giving us 32 GB of memory and 8 CPUs. So let's look at this. So this is already there. I'll select the instance and start the instance. Once the instance is started, I should be able to see the instance going into the pending state, and from here this would be going into the running state, and we should be able to log in. Again, if you see, once the instance comes to the running state, I should be getting an IP address, and this should be different than the one that we already used. The first number looks the same, but then the rest of the IP address absolutely looks haywire. I could give in the ADMI administrator credentials. I know you'll not be able to decrypt the password, but it's worth giving it a try. Oh yes, it's working, and let's try to decrypt the password and log in. So as you see, we have now logged into the server, and we should be able to go to the login screen comparatively quickly, because this is just a reboot of the server, and this already has higher configuration on it, which should allow it to log into the server quickly. Go to the task manager. That piece of software is taking some time, but then if you go to performance CPU, you will see that there are 8 virtual CPUs and almost all 31.6, that's 32 GB of memory available on the server. Now if I had to downscale this server, that is scale down the instance, I'll again follow the same process, stop the EC2 instance. Again, we patiently wait for the instance to go to the stop state, and once this goes to the stop state, we would select, in order to scale down, we would select any configuration which is lower than 8 CPUs and 32 GB of memory. So that is, let's select T3 medium, wherein we will select 2 CPUs and 4 GB of memory on the instance. So the instance is stopping, and it should be as simple as changing the instance type and starting the instance, like we discussed in the scaling up process. Quick thing to note is it's not always advised to scale up and down the instances on a regular basis, because this actually contains a downtime, right? So these kind of instances, right, when we are trying to downscale them, it should be done for only purpose of saving costs and making sure that the resources are overutilized. I'll go to T3 medium and click on apply and start the EC2 instance. So this is now started, and if you see, the IP address again would be changing, which is now 54 dot something, and I'll go to the settings, click on connect. Should be able to connect soon. Let's try with the same password this time. Let's try the same password that we already had, and if you see, we are now being allowed into the system, and this should be giving us the login prompt. comparatively might be a bit slower because this is containing rather the less amount of CPUs and less configuration of memory. But then if you realize we are not running anything on the server, so that for that reason the CPU, even though we are just using two CPUs, the utilization is not anywhere near 100% but just 20% or like hovering around 1 and 6%, and the memory is also being underutilized as of now. So this is how we log into the EC2 instances. We scale up. So this is how we scale up and scale down instances depending upon the utilization and the need for the change. So this is how we scale up and scale down EC2 instances. This is purely dependent on the amount of resources that we need for our computation or the applications to be running smoothly. If we believe that a downtime is possible, and in particular scenarios like a database server, we could go for scaling up and scaling down. And in some particular instances, it's always better to do a scale out and scale in. We would be discussing further on when to use scaling out and scaling in specifically in the next video. Until then, I hope you liked the current video. If you liked it, please share this and hit the like button on the YouTube prompt so that the algorithms pick up and this video reaches out to many people. Thank you so much for watching. Please subscribe to the channel. Keep having a great day.